remember what an exponent of 0 does? It makes it 1, which is kind of weird. Does anybody know what a negative exponent does from grade 9? What is 3 to the minus 2? It is 1/9. Can you explain why those are true mathematically? Or are they things that you maybe just memorized? So the first thing that we're going to do today is try to use patterns and mathematics to describe why anything to the exponent of 0 is equal to 1. And actually the pattern's quite simple. Let's start with a base of 2. If you did 2 to the 1, what do you get as an answer? 2. If you did 2 squared, and I'm going to write this in a column on purpose. If you do 2 squared, you would get 4. And if I did 2 cubed, I would get 8. If I kept this pattern going, tell me what I would write above this side. And tell me what I would write above this side. And I put an equal sign in between. What would be the next one if I keep going upward? It would be 16 here. And what would I have on this side?
2 to the 4.
2 to the 4. That pattern wasn't breathtaking. I hope you realized it was a really easy pattern to see that on the left, I was just going up by 1s in my exponents. And as my exponents go up by 1, what happens on the right? It doubled, it doubled, it doubled, it doubled. But the beautiful thing about patterns is, yes, I see the pattern, I could keep going up higher, but wait a minute, what if I decided to go the pattern in the other way? What would be right below 2 to the 1? 2 to the 0. And if I kept the pattern going, if I'm going backwards, what am I doing when I go 16 to 8, 8 to 4? I'm dividing by 2. And I get 1. So most likely up till now, you've always just either A, memorized that anything to the 0 is 1, or B, forgotten completely and had no idea. The hope is here, by seeing this pattern, it explains why 2 to the 0 is 1. It also explains, if you kept the pattern going, what would be next? 2, 1, 0, negative 1. And if I kept the pattern going on this side, I'd have to divide by 2. And if I did it again, I'd get negative 2. And if I divided by 2 again, I'd get 1 over 4, which happens to be 1 over 2 squared. And it explains our negative exponent rule as well. Does this work with other numbers? Let's check. Let's check if I started with a base of 3. 3 to the 1 is 3. 3 squared is 9. 3 cubed is 27. 3 to the 4 is 81. I'm doing the same pattern, right? I'm going up by 1 exponent, and with powers of 3, I multiply by 3. So going in the opposite direction, 3 to the 0 would be also 1, because now I have to divide by 3. So 3 to the minus 1 would be 1/3, and 3 to the minus 2 would be 1/9, or 1 over 3 squared. So often, students memorize the 0 exponent and memorize negative exponent rules. I think seeing this pattern really helps you understand why they're equal to what they're equal. Now I'm going to cause your brain to do something a little bit problematic. What should that equal? 1. Okay. Should equal 1. 0. Well, let's look at some patterns. What is 0 cubed? 0. What is 0 squared? What's 0 to the 1? So according to this pattern, 0 to the 0 should be 0.
Wait, how you define by 0?
Okay? We're just looking at a pattern. Or someone says, no, but I'm looking at this pattern. 3 to the 0 is 1, 2 to the 0 is 1, 1 to the 0 is 1, 0 to the 0 should be, according to this pattern, 1. Does this pattern make sense? Does this pattern make sense? The answer is, mathematicians don't like it when there's two patterns that make sense. This just doesn't work. They call it undefined. You type it into your calculator, you're going to get an error. They haven't decided. They're like, yeah, this pattern kind of works, this pattern kind of works, but they contradict each other. So we'll just say it doesn't work at all. It's one of the things that doesn't work. You have a few things in math that never work. Can you divide by 0? No, not allowed. 5 divided by 0? Not allowed. Can you take the square root of negative 3? Not with the real numbers. Not allowed. But with any other base, positive base, you can do anything to the 0 is equal to 1. All right. So here's a word for you that we'll use a fair bit. You might remember this word from dividing by fractions. They say you need to multiply by the reciprocal. So we can make a statement that the reciprocal of 2/3 is 3/2. So if you take a fraction and flip it, it's the reciprocal. And that's sort of what happens with negative exponents. Any power with a negative exponent is equal to the reciprocal of the power with the negative. So if you had 3 to the negative 2, you flip that fraction, but change the exponent to positive. If I had something like this, and the negative was on the bottom of my exponent, I could flip that and make my exponent positive. So the negative exponent rule allows you to have a negative exponent, but it doesn't matter where that negative exponent is. It could have started in your numerator, then it would flip to be in the denominator. If your negative exponent starts in your denominator, it would flip to positive and be in your numerator. So usually when we have to evaluate negative exponents, the first thing we do is we write it with a positive exponent. So 7 to the negative 2 will be 1 over 7 squared. And then that's something you know how to do, because 7 times 7 is 49. Exponent rule from grade 9. If you have an exponent to a fraction, that exponent goes to everything in that fraction. So that negative 3 would go to the 10, and that negative 3 would go to the 3. Then the negative exponent rule would say the 10 to the negative 3 I could write on the bottom as 10 to the positive 3. And the 3 to the negative 3 that's on the bottom, I could write the 3 to the 3 in your numerator. This will give me 27 on the top and 1,000 on the bottom. I mean, I don't have to write over 1 for this one. Ooh, that's scary. I don't have to write over 1, but I'm just showing that it moved from the denominator to the numerator. And if you have 5 to the 4, that's 5 times 5 times 5 times 5. Anybody know what 5 times 5 times 5 times 5 or 25 squared is? 625. couple more examples. If you have a 16 to the negative 5/4, the exponent doesn't flip, just becomes positive. The whole power is what flips. So the base is 16. The exponent is negative 5/4 in the top. Now it would be 5/4 in your denominator. Do you remember how to do these ones from last class? I'll do an extra step in here. We'll do the 1/4 part first, and then we'll do the power of 5 second. And the 4th root of 16 is 2, so you would get 2 to the 5, which is 1/32. Then we have a fraction, so the negative would go to the top, and the negative would go to the bottom. Negative exponent rule means that we'll change them to positive by changing or flipping the fraction. So we get 36 to the half and 25 to the half. Do you remember that a half is a square root? So the square root of 36 is 6. The square root of 25 is 5. And this last one is, can you type this into your calculator? They tell me that S is 1.5, so I replace the S with brackets and 1.5. It's to the exponent of 5/3. And they tell me that F is 0.3, so I plug that in brackets, and it has an exponent of negative 7/6. Your job is to type that into your calculator. I will put the answer up. And if you are unable to get the answer, then you don't know how to use your calculator in this situation and should ask. I wrote a lot of decimals, but therefore you can check to see if you've got your answer right. There's a homework at the bottom there. You can do that over the long weekend, study for your quiz.